My name is Nan. Welcome everyone. Good morning. So today we're going to talk about 5 considerations for a modern data analytics framework. And with me, I have a couple of presenters, Greg Fritz and Matt Werman.
Hi, hello everybody. Hello.
And I go by Nan. I have a much longer first name. So a couple of housekeeping points. Microphone on your side will be muted through the presentation. We have some time at the end for Q&A. Please capture your questions in the Zoom chat window, and we'll address and get to them, as much as we can fit from a time standpoint. So a quick round of introductions. CoStrategix, we help organizations become data savvy. We've been around 2006. We lead with digital data strategy workshops, leading to initiatives. And some of the customers are dialed in today. We appreciate the opportunity and your time as well this morning. So we do quite a bit of data science work today. Digital commerce, app modernization have been some of the work streams we've strongly led from a market standpoint, and they continue to be. But today, very heavily focused on data science. And these are some of the customers we've had the opportunity to work with. So today we're going to talk about modern data framework and why should one pursue modernization of your analytics, right? So there ought to be some business drivers. We'll explore some of them to get started. Then we'll look at a couple of footprints from an analytic standpoint. A logical footprint, which basically talks about different components of the framework, and then a more of a technology footprint, which reduces that logical footprint into technology components that you can, kind of comprehend, put your arms around that piece. And then a few considerations as you architect such solutions. What should you keep in mind? More from a business tech standpoint. And then a couple of implementation examples. We've chosen 3 examples, one on AWS and another one on Azure. Today, most of the data frameworks are implemented on cloud, so we've chosen those 2 examples. We also have a third one where we are using a lot of open source software framework using Cloudera stack that we'll talk about. And then, some of the implementation considerations more from a business standpoint of budgeting and how do we set expectations inside of the enterprise once you're convinced that you have to approach this. And if you are already approaching this, that might be certain pointers there. And then we'll end the conversation with Q&A. So that's the agenda for today. Quite a few slides. I'll keep a certain pace and hope to answer any questions that will come up along the way. So let's look at some of the business drivers, right? Today, the IT technology landscape is changing. Especially from an IT standpoint, it was very technology centric, keeping systems up to date, operational systems that will help run the business. That was the focus. Today that's changing to more of a customer or information centric model. It's not the servers and the software and the licenses anymore. It's the outcomes that drive, that are driven by those assets. IT was not necessarily participating in the overall strategy making process at all. Today, that is emerging to be a central to the business model itself. So technology is at the center of everything a business does. And the best example you may have heard of is Domino's, right? They're really a technology company in the business of they're making and delivering pizza. That's how they build themselves. And today, most companies could, just copy, apply that concept to themselves. Every company is going to become a technology company first and foremost in the business of certain core things they do in the marketplace today. And from an infrastructure standpoint, we used to buy servers, do some of the capacity planning and all of that in ways you would basically have pets at home, take a lot of good care of the pets, that type of a mindset, as opposed to cloud today, right? Is more of a cattle mindset, right? You need a server, you can boot it up. So it brings a lot of elasticity in the way you manage. So that's also another dynamic. Governance was based on truth, right? Say you had two tables and you matched up, cross-reference the two tables, and you could explain every bit of relationships within your database. But today, that data and the scale of data is so large that you have to employ a trust model, right? So 80% of the data may be matched up. The remaining 20% may have different flavors, the long tail, right? So your systems in the way you consume data has to be based on a trust-based model. So it's not 100% match, maybe there's 80%, and then you do certain things with it, that type of thing. Same with organization. Everybody in the company is becoming a tech user. IT used to be the most savvy team from a tech standpoint today, but that's spreading across. CFOs, COOs that we talk to are pretty data savvy, and they are asking for quite a bit of data and analytics. So anytime we set up an initial call with CEO or CFOs, analytics is top of their mind, right? And both defensive and sort of offensive strategies as it comes to analytics. And we'll talk a little bit more about that in the next few slides. And then similar other points, right? I'm not going to go through that, but efficiency and low risk is what IT was always measured upon, right? Low cost and uptime, and take less risks and measure twice and cut once, that type of a mindset. That's all changing. Can you drive new revenue streams? Can you be agile? Don't do everything, just do minimum, learn and apply, and in rapid cycles. So that's one concept of how the landscape is changing. Analytics itself, right, is also going through a change. So there is a lot of data today. The rate at which data is produced, raw data, is phenomenal. And those things are driving what I call as the descriptive supports. So you're driving in your car and you look at the rear view mirror. The picture you see that's behind you is essentially what these descriptive reports are. It's basically what has already happened, something from which you can learn and course correct going forward. So that's kind of the baseline, right? That's where everybody gets started. But the distance or gap for an analyst in the company to analyze, make decisions, and take action is substantial. But as you trickle down, another level of maturity is a report is also produced here, but it also tells you why certain things are occurring. Why is there an upward trend or a downward trend? And then, you can use that to make a decision, but the amount of analysis needed is quite low. And as you go further, you're now going more offensive, which is more predictive, right? What's going to happen given how things have shaped up in the past. The analysis there is, how relevant it is that this prediction model is, practical enough for you to decide and take action. And then there are prescriptive systems. We haven't necessarily implemented much of the prescriptive type analytics yet, but quite a bit of predictive is in play as we speak. And some of these predictive models are also operationalized from a production standpoint. So this is how analytics is also evolving, right? So you have a changing landscape, you have a changing or, dramatic new possibilities that analytics has opened up because of cloud, because of data, the ease of, performing these analytics due to open source software. And also like cloud services where you can pay per call or pay per use and pay as you go. All those becomes quite affordable. And even within an analytics, right, there's another point of view. There is like mode 1 and mode 2 type analytics, right? So when you say mode 1, it has a certain set of characteristics. Mode 1 is typically more operational type reports. This is what we call as defensive strategies. This is the set of reports that helps you preserve your bottom line, the operational profit or margins within a business. They're highly structured. Somebody who is looking at that report has dictated, I need this column, and by market, by DMA, by product type, and all of that. So it's highly structured. It's developed usually by your IT team, right? And it's developed and it runs on a regular basis. It's published. The control of publishing is still within the IT team. It's scheduled, distributed once a week, at the end of the quarter, at the end of the month. Those are typical type of frequencies. And I talked about defensive, and usually they are to do with what has happened in the business. Example of those type of systems are like SSRS types, highly structured reporting, crystal reports. Those are some of the examples we find in the market today. Compare that mode 1, right, to mode 2, which is more open-ended. You don't know what you're going to do with the set of reports. Give me like 30 columns. I'm a CFO, right? I'm asking you to give me like 30 columns. And then I'll figure it out, right? I'll apply a degree of my own analysis that I can't articulate to a developer. So essentially, I'm more tech savvy, so I can put those things together and analyze. So then IT's role becomes the enabler, right? It almost becomes like a utility model where you plug in your laptop into, say, electric socket, and you expect the electricity to flow. Likewise, the CFO would open up, connect into a self-serve portal, and he expects data to be there in a form with high degree of quality where he can run his own analytics and make business decisions. So it's business authored, it's collaborative. Once you make that, right, they can share those reports, dashboards with different other users. It's agile, self-serve. It's usually offensive, right? The type of things the business user or that CFO, COO is thinking is very unique to that business. It's not some third-party vendor can come and write it for them. They have a very nuanced understanding of the business, and then they are, building that set of insights for themselves and their teams. It's also forward-looking, right? They themselves may not be in a position to apply predictive, but these, say, BI tools are also being augmented with machine learning. So it's not just a COO figuring out what he needs. The machine also can, the software can also tee up 20, 30 different dashboards. And you may like one, and you can say, I like this, and it'll learn from your likes, dislikes, and it'll start teeing up much more. So it's augmented analytics, meaning you don't have to go set up every single thing. These systems are quite capable of determining that. And they're also exchanging that knowledge across industries and across platforms as you kind of tap into it in a way that doesn't hurt your competitive aspects of it. But based on that, right, say if you have a table called G, right, it may determine that is a gender table, or if it has ADDR, it may automatically determine that it is an address field, right? So those are some of the things these systems can consult a global vocabulary and determine, what the schema and the structures look like, and operate that way. So this is the whole mode 1 and mode 2 side. So we looked at the changing landscape and the role of how analytics is and how these modes are. So if you look at the fourth component, right, the data assets within the company, they're becoming very defined. That there's different types of assets, like from your web-facing, consumer-facing systems, or web applications. Any partner data, open data that's available from government sources, social, operational data, and dark data. Dark data is anything, say, within your email that once it enters your enterprise, it's not available to anybody else. It's siloed off, but there may be some substantial insights there. It may be, um, uh, if you have a parking system, it may be a car in, car out type system. That's only, within an island of that. You cannot pull the data. That's all constituted as dark data. And most important of all this is the third-party data. There is a huge fabric of data providers that provide all sorts of data, right, at very uh, competitive price points. And so because of that, right, when a company looks at all of the data and creates a catalog of different data sources, they supplement that with third-party data, and that substantially increases the value that they can create. So what we've seen in a couple of customers is the amount of third-party data and how that is informing the analytics landscape for them, right? As they drive, that is significantly much higher. So given all these trends, right, that begs for a system that basically can handle these different dynamics, right? Users asking for self-serve, data sets that can be governed in a central way without having to, govern the access to the data itself. Being able to assimilate third-party data sources easily without having to, write a lot of code. And then also being able to scale this into future as analytics evolves into that prescriptive predictive piece. Can your footprint that you have today can automatically scale, or do you have to throw it away and kind of redo it from scratch? These are some of the things that are the business drivers today. So if we take those as inputs and we feel like, yep, that pretty much is a good business case, something that we can distill and convince the C-suite in an organization, or even they are the ones coming to you, right? Today, we see quite a bit of that as well. So let's look at, given those set of business drivers, what does a modern analytics footprint look like? So we'll look at two things, the logical footprint and the technology footprint. So if you start with the logical footprint, right, it'll typically look like this. You will have data sources, different types of data sources within your enterprise. Operational systems, marketing, third-party systems, spreadsheets, even physical forms. We have customers who are basically scanning forms and using OCR. So the data quality may not be that great. Sometimes, errors are introduced in the data. So you have to look at this from different perspectives of quality, and there's about 5 to 10 dimensions there. But all of that is being ingested, inside of a general module called data acquisition. There's different ways of acquiring the data: APIs, batch mode, streaming from devices, and so on. And then you're storing it in a big data store. So when you talk about big data, right, the key difference is that it is a data store. And when you store data in a big data store, it's not necessarily conducive from a querying standpoint. Oh, sorry about that. Let me see here if I can quickly go back. Apologies. Yeah, I may have touched by, I may have been an electrical charge. So going to the logical thing, right? So there is usually an offline and a real-time processing to that. And there is a in-memory type persistence. And you'll have a set of aggregation or data models. And these data models may be intelligent. It may just be a simple model which combines data into a usable form. It may also have some degree of machine learning that is built in. And some data management interface that gives you ability to manage the data, govern, secure. And there's also something called data ops. That is also a good interface point, right, that these systems provide. And those data sets can be made available to your data science teams and data services, which open up data insights to external systems. It could be KPIs, it could be applications and so on. So these are the typical components, right? Some in-memory, a big data store acquisition, and some models and real-time processing with these different sources. Now, if you look at a real technical implementation, right, it looks somewhat like this. Again, different data sources, a little more defined here. And data acquisition, you will have a set of ETL tools. So a lot of mode one type implementations in organizations today do not have a defined ETL tool. So they tend to write code in order to acquire data. Think about third-party data, right? Every time you get some of that or you buy, you're going to be writing a little bit of code. That has to be kept up. So there's a total cost of operating that piece of code as well. And then there is open source type data acquisition mechanisms or software like Kafka, which provides you a lot of different capabilities and connectors to pretty much any data source out there in the world. So we use that for quite a few customer implementations, and it's a pretty good workhorse, right? And it can scale very well, especially if you're acquiring data from something like a device at a certain rate. You can basically boot up multiple instances and scale that quite well. So all of that streaming data coming in from these things, right, are stored in a big data store. And you can look at HBase, you can look at data lakes, you can look at different other mechanisms. And we'll go through that. If you were doing this on an Azure, what are my choices for a data lake? If I'm doing this on AWS, what are my choices there, right? And there could also be a NoSQL type database. And so that's, again, a choice you make depending on your business needs, the data source you have, and how you plan to use that data going forward. So that's the third layer. And then from there, you can actually begin to generate some insights. You can write some of these APIs, and then you can also feed it to your data warehouse. And some companies are going to be exploring graph databases. One of the large retail client we have is using a graph database today, and we're feeding data sets into that database as a project that we're doing for them. But they bring different capabilities. I'm not going to go into each of those. And you also have data marts and different other consumption data store engines, right? And these are specialized in the way the data is stored and helps you consume query and that type of thing. So the data lakes are more focused around storage, right? And very large scale storage where you can throw anything structured, unstructured into that, and you don't ever delete any data that you acquire. I mean, I say that because data is gold mine, and today data storage is cheap, and you don't ever want to throw away because you can look at 5 years past data and come up with certain analytics and insights. But there may be a case to clean up every now and then the very micro level data.
Especially on the cleaning up, if you have PCI concerns or data that needs to be removed from the system from a security perspective, having a natural sort of purge or archive or moving into very cold storage as opposed to active live storage would be needed.
So that's a great example, right, of where you may need to curate and archive and delete purge data as well. But see, most companies or most organizations today are essentially in this layer, and they're trying to, get to the next level of analytics. There is a whole front end side to this piece, understanding all the sources and how you kind of approach this piece, right? So these are not like replacing concepts, right? You can have a data warehouse, data mart, and all of these, and you kind of reverse construct this picture to bolt on and kind of seed the data in your data lake first time, maybe from your data warehouse, and then you go integrate these systems upstream, or you may continue to get this data from data warehouse since you have systems already integrated through your data warehouse. So those are the choices you make mostly from a cost and budget standpoint. And is there any value if you have to go rewire everything in this particular way? So going forward, any new sources come this way, but anything that's already pre-integrated with data warehouse, you can get that data set in. But if you're throwing away any data because the warehouse was not flexible enough, that's something to look at and make sure you bring that type of data into this store as well. So all of these then will drive your self-serve analytics, right? Because we see a lot of customers actually are pursuing, may have data warehouse and some mode one reporting systems, but not necessarily. And then they are focused on, where, how do we make this data available to downstream users? But this is one way you can bolt on and complete these two footprints, but keep in mind that these other capabilities are quite important to deliver on those business drivers we talked about. And then the second use is more of the application insights. It can power, TV screens, dashboards in hallways, and help, employees, customers, partners all track KPIs and address behaviors there, drive that data literacy within the organization. And also applications can all be made highly intelligent. So we're working with a customer where we're feeding some of these APIs that provide highly intelligent insights into the application. So these applications are products that are sold in the market. And so imagine how these products compete with other products with this AI infused intelligence, right? And because of that, these products will have a competitive advantage and can sell more from a market share standpoint. Finally, your data science team, right? Everybody uh, probably are looking at this. A lot of CEOs talk about this, and they've heard in their digital transformation type seminars, but basically taking the data from these systems and driving and writing those models that drive some of these application insights as well. And again, those data sets can come directly from the unstructured data or from highly structured data as well. So that essentially is your technical footprint. So I'm sure there is quite a few questions here, but the next set of sections is essentially how does this footprint really look in the in an implementation form. So this is where we look at a Azure or AWS type implementation, and then we look at some of the 5 consideration. Actually, I moved the 5 considerations up before we talked about it. I think it helps to have these considerations in mind as we look at some of the implementations, right? So, so let me go through these 5 things first, which is, a solution architecture should minimize any redo or throw away investment as you evolve towards the data and analytics maturity. Number 2 is sources of data. It's not necessarily data from your organization or enterprise that brings value. There's a lot of third-party sources that play a major role in, complementing the value and really makes your data highly insightful. The third one is there is a whole emergence of cloud-based serverless type architectures. One of the architecture we'll talk today is entirely serverless and highly scalable, pay as you go. So you don't have to, worry about how much of storage or computing I have to have, even inside of a cloud, right? You're not even looking at instances or like compute instances from a capacity planning standpoint. Fourth one is data warehouse integration. We talked about this with the data lake. They are complementary systems, right? They are not opposing to each other. You take one and you evolve the other one. And the last one is the loose coupling architecture, right? So a lot of these systems are evolving. What's really well performing today, right, may be superseded by another one next in 6 months. So we have a big contingent from CoStrategix headed up to the Strata Data Conference in New York. I highly recommend that conference. But basically every year we go there, the previous year's top technologies are no longer relevant, right? They're kind of falling off the thing. But basically you want to have a loose coupled architecture that if you're using some of these components, you're not throwing away the entire ecosystem. And usually there is a good go forward path with these newer technologies, as you see in the marketplace. So those are the 5 considerations. So if you take these 5 considerations and then kind of look at what an architecture might look like, the first one is Azure. Matt will lead us through that, the flow and the building blocks of this implementation.
The Azure implementation here is a sort of a typical rollout of being able to pull in data and preparing it for Power BI, building out, getting your analytics, reports, dashboards, maybe some CAN reports for the organization, and be able to do some self-service. The main components of it, is the Azure Data Factory and the Azure Data Lake with the data warehouse. Those 3 pieces together perform a bulk of the sort of the workhorse of preparing the data and getting it ready for the users to consume. The data factory itself, when Nam mentioned before about the ETL pieces up front, Microsoft is investing heavily into this piece, where it does perform a lot of traditional ETL type services where, connecting to, say, an SFTP location, pulling in files. It's able to connect to REST APIs provided by an external system, internal databases, other linked services. But it's also starting to blend and provide more analysis behind the scenes. The ingestion piece, along with some of the prep and training of Databricks, is starting to merge together where Data Factory is taking advantage. So we can put more into the flow. It's more ingestion, prepare the data, get everything into the data lake. So we have our raw data, how that data then is transformed, and then the Data Factory itself kicking off into the warehouse to store and build out those models. The data lake itself, the version 2 of the data lake that Microsoft provides is much more performant, has a lot more capabilities to it than the previous version to storing the data and getting it processed in the system. Today in the data warehouse, in the solution that we're working on, the data warehouse is integrated directly with the data lake. So we're able to query, pull data out directly from there, perform some deeper analysis and models to prepare for the Power BI users. One of the interesting things as you start looking at analyzing the data that's in the warehouse, Power BI obviously can go straight to that data warehouse and start pulling out and modeling it there. But we can also pull it out directly and have smaller data sets available for users to use, whether that is being uploaded to PowerBI.com, the online service, or down to the desktop. And one thing to note, behind the scenes in PowerBI.com, the service, they actually use analysis services behind the scenes. You don't know it's there. We don't really care, but they use it to help power and make the speed of those platforms work nicely. You may find that your local desktop version of Power BI is slow, and then when you upload and publish those reports, they're nice and fast. So analysis services helps abstract out that data, so you're not reliant on having a large capacity warehouse running to keep up with speed and capacity of the reports.
And so this particular client is also going to scale where a small data science team will start tapping into this data. But as you can see, they're kind of along that maturity continuum, trying to get there.
Yeah. And the latest big investment is Azure is bringing in Databricks, the open source tool, and using that behind the scenes. So as we start using more and more data factory tools, we're finding that behind the scenes, it's really just implementations of Databricks. So it makes it easy to work and pull and transform the data and integrate with these tools without having to know a lot of the internal background. So it makes it easier for operations teams to manage and monitor and alter if needed. Thank you.
So that's on the Azure side of things, right? And if if you look at the next one, which is more on the AWS side of things, this is for a transportation logistics customer. We're acquiring data from a multitude of transportation vehicles, the engine and the driver behavior type data. So as these vehicles are added, right, you shouldn't have to go understand what is that data acquisition capacity or bandwidth that I need. All of that, right, basically is kind of made simpler, where they all call Lambda services on from a ETL data acquisition standpoint. Then you got simple notifications as and when data sets are there, and then it pushes it into a simple queue service, which basically enqueues the data sets. And there is a DQ process that basically uses a Kinesis, like a workflow tool, where you can apply some transformations and some correlations and clean up data quality, those type of things, and you will store it into Amazon S3, which is your data lake. So you take these architectures and you kind of put it into that generic technical footprint. Almost every component has a cloud service here. But you can see everything is a cloud call, service call. There is no server instance we are buying on the Amazon. So that is highly scalable. You can call any million number of Lambda functions. It'll just scale for you, right? At least that is the promise. And we've not seen anything to the contrary so far. And so once I store it in the lake, right, it powers a more friendlier structured database, which is used to drive visualization. It is also used to drive the data science team. There's also a couple of data science or predictive models that we're writing that feeds off of that particular data set. It may also use data from the data lake, but at least in this representation, it's going through a structured, more of a queryable type database. And then on the other side, it's opening up a set of insights, right? This is a key value type store. It's taking the same data set and making it, in a slightly different structured form. You could argue these are like parallel concepts. And this particular data structure, the way it's aggregated, helps drive few applications for the client. So they are building application that has a significant point of difference in the marketplace that other competitors don't have today. So that's kind of the business return, right, for an investment in such an infrastructure. And there is no heavy upfront investment except for the first time setup, which is more like project work. But for the infrastructure and license itself, everything is pay as you go type model. So as I say this, if there's any question, please capture that in the Q&A side of the Zoom tool, and we'll get to those questions. Yeah, shortly.
So before we move on, I think this is just one point I want to make about the two implementation architectures that were discussed. I mean, these are an implementation architecture for a particular purpose. And the thing that's important here is there are other tools within the various cloud providers, whether it be AWS, Azure, or GCP, the Google Cloud. Each one has a similar set of tools, and they have, in certain cases, multiple tools based upon the implementation. For example, we talked there about Data Factory for Azure ingestion, but Azure also has an event hub, right, which is more aimed at like IoT applications where you're getting mass volumes of events. So I think the key here is these are particular implementations based upon the business need. Part of what you need moving forward with your data and analytics is a skill set that understands the various tools available within whichever cloud provider you choose, or if you're doing in-house, to piece those different tools together to meet your business needs.
So if we go, the last example, we're using our Cloudera stack. The Cloudera stack is also an open source. And you can see a lot of these software solutions, right, are built using open source software. That was another key factor, right, for the whole data revolution. Is what was once limited to few big, large companies, right? Now anybody can use these set of software and drive these insights. But there are challenges making it all work consistently, and that's where you can see something like Azure using Databricks, which uses Spark, Kafka behind the scenes, all orchestrated in a nice way, and you're paying for that, as you use, mostly not for the software or license itself, but for the whole orchestration, like making it work consistently 24/7. That's kind of where the shift is from licensing revenue to more of services, cloud services revenue. And so this particular company is sitting on a lot of unstructured invoice type data. And that's kind of what we are processing for them in a similar type of footprint. We are writing a set of intelligent classifier models which can classify data incoming at large volumes and drives different data services and connectors. It says future here, but these phases have been also implemented. And drives these insights from an end user standpoint. And a lot of different tools used here. HBase is the data lake, Kafka is the data acquisition engine, Woozy is the data workflows, which captures all of the transformations there. And then there is a set of software for governance and managing any type of aggregation that needs to occur. Impala is, again, a more structured, a queryable engine, which takes subset of data from HBase and makes it available for business users to query. And, we have over 2 billion data points on 24 terabyte database. That's just some of the statistics around the large scale implementation that we have today. So we saw how the business drivers were and, what some of the logical technical architecture and about 2 to 3 examples of different ways you can bring that into real life. So where do we start, right? So most of these challenges, there are technology complexities, but they may not necessarily represent challenges today. With a good engineering team, you can actually make that happen. The challenges are mostly, where do you go? Do you have a map before you start driving, right? This is where we work with a lot of organizations, define their data strategy, right? All the way from how you craft the vision, what are the metrics, governance, all of this helps communication with the C-suite and ensures that there is budget and outcomes that are aligned with that. And defining a meaningful why is very important. Like, what are you going to do with the data, right? Are you going to drive insights to preserve operational margins? That's fine. That's a very transactional why. There is a larger why, in how it ties that to your end customers. Defining that will make quite a bit of difference in how, you rally people, both C-suite and the rest of the organization, and drive them towards more of a data-driven mindset from an organization standpoint. This is about also securing resources and funding. There's very different set of skills that is required to put this together. Not all of those skills are required all the 365 days within a data ops type setup. Sometimes you will only need them at certain points in the project. Having ability to dip into external partners for those capabilities, that would be a key requirement today. Because if you're looking at hiring and one person doing all of this, there is going to be complexity that and costs that you wouldn't necessarily be able to justify. If you are specific, capture the use cases, what you can do, and be very specific, right, about 1 to 5 use cases that we could go to C-suite and commit to that, and then use that as a roadmap to go fulfill on that piece. So doing that will bring all of this complex concepts down to a practical level. You're tying it to either top line or operational efficiency, and those are ways best to justify funding. Creating data literacy, we talked, right, is a big complexity we see in organizations today. Not everybody is data driven. Even if you give them an Excel spreadsheet, right, with very insightful data, they were not consuming it. And that will not change if you put a very colorful dashboard, right? So there's different ways to, build, this is essentially a change management process. If you're going to put some KPIs, how is that? There has to be some mechanisms that push those KPIs down and some mechanisms that motivate them to, some pull mechanisms. So you have to have both push-pull mechanisms to make some of this type of implementations successful. Identifying some champions and having them amplify will be good. Proof of concepts and some organizational changes as well, driving KPIs, building that into reviews and compensation. Some of that, all of those things together will begin to move the needle on data literacy within organizations. So that brings us to a close here. We have about 15 minutes or so. If there is any questions or other comments, we'll keep going through that. But essentially to recap, the business drivers. We looked at different factors that are in play. Some of the analytics footprint, logical, technical. The 5 consideration and examples of AWS, Cloudera, and Azure. By the way, Cloudera is not a unique cloud services provider, right? It's a stack that can run on Azure or AWS, but it's not necessarily using cloud data services. It's using software that you have to install. So it's a little dated from that model, but that's where some of these cloud providers are going to bring some intense competitive pressures by turning every software out there into a cloud service. So you can just pay as you go kind of a model. So that, and then some of the considerations. So we're at the end of this presentation. Any other thoughts you guys have? So that's it from our side. So any questions?
I was going to say the only thing is trying to really, at least from an Azure side, trying to keep up with everything that they're doing, watching out for the webinars and keeping up with newsletters, because there is a lot coming out, making data processing and analytics a lot easier, seeing how the roadmap is evolving and processing data. Where last year we were looking at having to spin up a VM, where now a lot of that is serverless. Just 1 year later, it's been very nice to see.
And so that's a good point. One of the customers were looking for a specific feature in Microsoft Power BI, and we did some research and told them that feature doesn't exist. And that mail was processed by them 2 weeks later, and Microsoft had released a patch, right? And that feature was available. So we had to explain, hey, how did we miss this? We didn't really miss it. It just got implemented within the 2 week period.
It's a dynamic space.
Yeah, they keep releasing those updates. We are a Microsoft partner. We're also agnostic. We do have different implementations. So really quick, if I go into some of the things we handle, Tableau is a pretty big workhorse as well, Power BI, Azure, and some of these building blocks. This is our play box from which we use all of these different widgets to implement. But we most, primarily start with crafting with data and analytics strategy. There may be some already there in certain organizations. We help clarify, refine that to more modern principles, and then help align those to business priorities. We do have some ready to go components, which are also open source, right? But we can deploy that and get you to a point of operations really quick. And the cloud strategy becomes defined as a part of that, right? Some of customers are not using cloud still today to a large extent. They may be dabbling with an application or two on the cloud. But again, this is another way to delve into more of cloud services. In fact, if I wouldn't even start without a cloud today on an initiative like this, because it's so important, both from a cost standpoint, scalability, and future proofing standpoint, that you actually use cloud services for all of the data analytics work. Again, data science, taking that through that continuum, right? Data engineering, insights, and data science. We do that, and data ops as well, going through ongoing support. So that's a little bit of shameless plug. We appreciate all of your time today, and we'll be sending out a quick survey, and appreciate any feedback you can give to help us make these webinars better. Thank you for your time, and have a great rest of the day.